If we want to make child classes with a parent laser rifle to have many functions, such as shooting and aiming, they would rely on the component pattern. To quickly define what it is taking each element of an object and convert it into smaller parts that can be added as necessary. Otherwise, it acts like a container that holds the component as it does all the work. So here in the laser rifle, you can see the rifle has many functions. The equipper, the aimer, the shooter, the shooter laser, and somehow it has a slicer, but supposedly for sharp like weapons. And as you see right here, um, the sniper rifle also has the equipper, but they happen to have two, um, I would say like two different components that are special types. So if we could put an action here, this corner right here is supposed to be for the laser rifle. If I could show it. There we go. So you can see right here, this is supposed to be the laser rifle. By following the lectures, we decided to make a code. So here, when it comes to weapons, I will make components that each weapon can do, such as the aimer, for example. I want the gun to aim, so I would rather make an aimer, which is a component that will make the gun aim. If I want to shoot, I would rather make a shooter, which is a component that allows you to shoot. There's also special components, which are special types of actions. As you've seen in the previous videos, there were shooter lasers and shooter rifles, for example. Having a health component is one of the major aspects in game development. Here we have two custom components, the current and the max health value, along with the functions provided by following the lecture video, which is take damage, heal, and die. We can apply those changes to the health components by setting up those functions. So let's say I were to set up the max health value to 5, then the current health must be at 5. It doesn't have to be 5, it can be more or less than 5. However, there are cases where overheating needs to be avoided, or sometimes it is necessary. So if the current health value happens to be more than 5, then that is considered overhealing. If we want to avoid that, then the current health must match to the max health. So as you can see here, I'm going over to where this code was. And as you can see, if I were to press a certain key, the current health should be decreasing as it were taking damage. If I press another one, the numbers will go up in the current health, which means the cone is healing. If we want the character to actually die from taking too much damage, the actor must be set to destroy and the current health must reach the value of 0. As you can see what happened to the cone, because I initiated the kill code, which automatically sets the cone current health to the value of 0. If we really want to destroy the actor, then the character must have a function that's set to having life. So if we were to run over an instant kill object so many times though until our lives run out, then the actor is completely destroyed. To define the singleton patterns of programming that allows game programmers to interact with computers. Singleton treats as an object where there will be only one. It's possible to have a second, meaning if we were to check if there is another game instance that does exist, then it'll self-destruct. A pair can hold information about the game and provide easier access from anywhere in the codes, which means programmers can write codes to only one object that considers a singleton. Thinking back to the principles of OOP or OOP, it makes the process easier for game programmers when we think about the objects needed to make the game. For example, if we're making a monster catching RPG, the objects we need is a device that can tame or catch monsters, and items that can provide boosts to our tamed monster. Using the game instance will hold data the games know and persist between levels. It will never destroy once the next level is loaded, meaning we can keep our written data. The player's life mode is one aspect to include in the game instance. So if the player were to die, I would lose 1 life. If the health value if the current health no if the life value were to reach an absolute 0, then it's a game over. So as you can see, I forgot to set the lives are visible, which the player character should have 3 lives, but so for some reason, instead of losing 1 life, it's still the value still says 3. I may encounter some issues while following the lecture video, but the actor should be destroyed once the lives value reaches 0, which it still says 3, but it still works when the actor is, as you see, is completely destroyed. Deadlines are always the game programmer's greatest enemy when in the game's development phase. There are times when programmers had to decide whether they need to perform the easy way now or take extra time and effort to plan and organize. It's nearly impossible to avoid tech debt when choosing the easy way. Sometimes where game programmers can try to avoid that debt the best they can, and that is playing codes to reduce their technical debts without making the easy solution or the easy way too challenging enough. Reducing the technical debt is to ensure the written codes are cut into sections with only one performance. If programmers wanting to make codes modular, they don't have to rewrite and debug codes. They only have to worry about the single code or that single code because it can help them avoid tech debt in case of future changes. Like if they want to make future changes to their big game project, they only have to worry about that single code that is like the main source of their big project, or in cases like multiple projects they have, they only need to worry about that in a single code, not just many codes. Following the principles of OOP, programs can convert complex information to simple codes that are easier to understand. As the event driven, Unreal Engine allowed programmers to create events and call them for certain responses, which proves very helpful in organizing codes into single purposes. In case of times where programmers need to copy and paste blueprints to other locations, creating Margot or Margot libraries is the efficient way of copy paste blueprints from other code locations. Just don't do the old fashioned way of copy pasting, just perform how you insert node and functionalities. Feedback is one of the major aspects in every consoles and games development. Without letting the players know what has happened in the game, they may not realize the game is performing something important to either the mechanics, the game aspects, or they may have missed the aesthetic touch to the game's story. A player's character with no health bar UI is the worst thing to miss for a game because you wouldn't know if you're in the brink of danger or death, if you're actually alright, or if the damage amount you receive will take a lot or less of your HP. It's crucial to provide feedback or giving the players all relevant informations and UIs to understand what is happening. The UMG, or the Unreal Motion Graphics, is a commonly tool system used for creating UIs or user interfaces in games. By creating widgets, we'll define the performance of UI elements on screen. Once the widgets are given the definitions, then we can proceed to using blueprints to input changes and functionality on the widgets. In addition, UI can hold commands that allow programmers to tell the UI to update. Whenever certain meaningful events occur, a command code initially tells that UI to update or to make a change. So I can see right here what it means that whenever I ran into a landmine, that code would tell the UI to update or make a change, meaning that if the player were to hit a landmine, they will lose their HP, and that HP UI will change. And that UI of the health bar will change as I continue um, to touch more of those landmines. So I can see right here, these are the more examples of the for the UI scripts, which is showing the main menu and the game over screens. These are the blueprints, and if I were to test it out, you can see that it will lead me to another page by inputting the functionalities. Setting up the start menu will allow players to begin the game or quitting to desktop. So if I go to the main menu widget, this is how I set up the main menu or the start screen. If I go to the blueprints, this is how I set up the functionality of the main menu. If I go to the game over widget, the setup should be similar to how I did with the main menu. Also the functionality of the game over, except with a different nodes as well. If I go to credits, it will lead me to the credits page. If I go to quit, it will let me quit to desktop. If I press start, it will actually let me play the actual level of the game. Having a start screen is completely mandatory to almost every console and game development. So as you can see here, I initiate the gamer screen by initiating the kill code. Gamer screen is also important because if we want players to quit the game or to beat the game, or if their lives ran out, a gamer screen is required. As you see here, I show a few things to show that the level is actually reset by pressing the restart button. So if I want to click the main menu, I'll actually press main menu. If I actually want to quit, I would press the quit.